So here's the setup of our latest 18th project. We're using a microphone right here, and we're making the LEDs change to the amplitude from the microphone. We have an amplifier circuit here made with an amplifier chip, and then that amplified signal goes into A1 on the Arduino board, and we read that. We do perform some statistics on it, and we then output that to 8 different LEDs plus an RGB LED. So if I turn on some music, and this is uncopyrighted music, so I don't get in trouble. So you can see how that changes with the volume and the frequency of the signal. So it is quiet, it doesn't move, but as soon as I start to talk, it moves around. So that's our 18th project, and I'll show you how that works. So enjoy the Arduino. Hello, this is Jim with We Develop Electrical Products. This is our 18th project in the Arduino. We've modified project number 17 a little bit here. Project number 17, if you'll remember, was taking a aux cable from a sound source and pumping it into an input on the Arduino, and it was making some LEDs dance. And we were doing that by placing LEDs on some of the digital pins. What we've modified here is we're now going to be listening to the music through a microphone and making the LEDs dance to the output of a microphone that's been amplified. And this time we're doing it with a shift register rather than connecting every LED up to a digital pin. So how do we do this? Well, we have obviously a microphone shown here, and that microphone is biased to about halfway, about 2.5 volts right here at this point, and then AC coupled into the input resistor of an OpAmp. And this OpAmp is tied to 2.5 volts as well on the positive pin, to get it to be equal to the input here. And how much amplification do we have? Well, we've got gain. In order to figure the gain, it's just R18 divided by R19. So it's 1 mega ohm, or 1 million ohms, divided by 2K, or 2,000 ohms, which gives you 500 is the gain of this stage of the amplifier. But it's in the inverting pin, so the output's going to be inverted from the input. So as the input goes high, the output will go low. So what we're doing here is we've got a second stage to this LM358 OpAmp, and both of these chips are on one, or both these circuits are on one chip. This is the chip pinout right here. So we've got dual OpAmps here. So we're using the second stage as a unity gain amplifier. We've got 10K ohm for the feedback resistor divided by 10K ohm for the input resistor is going to be a unity, or number 1. And it's going to invert as well. So we're going to be back in phase then with the input signal. And still the gain is going to be 500. And then we take that and we put that into an analog input on the Arduino. So this is going to be sampling that microphone output amplified by 500 and read that on the A0 pin. And then we have 7 or 8 LEDs, and those 8 LEDs are driven by the Arduino chip or the Arduino board through a serial chip. And we've got control of the data line with the Arduino and the data clock, and then a register clock. What the register clock does is whatever's in the input stages of the shift register, when that clock goes high and then back low again, it shifts that to the outputs. And then we have an RGB LED. And these are all current limited by 220 ohm resistors. Same with our other LEDs. They're all current limited with 220 ohm resistors. And the RGB is controlled by a couple of, or 3 different pins on the Arduino. And we want those controlled by pulse width modulating capable pins. So we can pulse width modulate the signal to the RGB to get different colors. Now, just like all of our previous projects, the LEDs and the RGB LED have a polarity. And if we go to the polarity, the RGB, we're using a common cathode RGB. And this is the red pin, this is the cathode pin, and then the green and the blue. So that's the polarity of that. And if we go back here to our schematic, we've got blue, green, and red. And so you would just, and then we got the cathode here. And then the LEDs, they as well have a polarity. And if we take the polarity of those, we've got the anode, which is the positive pin, is the long lead, and then the cathode, which is the negative pin, is the short lead. So if you go back to the schematic, you want to make sure you hook up the positive pin to the output of the shift register and the negative pin to your resistor that ends up going to ground. So just like in all of our previous projects, in the description below, you'll have links to all the previous videos. There'll be links to where you can find this schematic. There'll be links to where you can find our Arduino script or sketch that we're going to be using, and all the components where you can buy those components. So those will all be in the description below. So without any more on that, we'll go to our sketch. And in this sketch, we're using a statistics library. And you get the statistics library off of GitHub. And again, in the description below, you'll find a link to the GitHub area where you can get this statistics package. So we include the statistics package, and then we've got some ints here and some floats. And one of our ints is an analog input, A1. That's where we're going to be reading the output of that amplifier stage of our microphone. And then we've got an int, which is a sound level. And that's what we're going to be storing the red value when we read the value of A1. We're going to be storing that in the sound level. And then we've got some pins here for our shift register. We've got a data pin, a clock pin, and a latch pin. That latch pin is again the pin that shifts it from the shift register to the output of the shift register. And then we've got our RGB, red, green, and blue. and they're assigned to output pins 9, 6, and 3 respectively. And we got some floats here that handle our statistics, which is an addition float, a mean, a standard deviation, a max, and a min. And we're all assigning those all as floats. And then we've got some unsigned longs, which are going to do some timing. We're using the timing to determine if a new song is playing or if there's a pause between songs, so we can restart the statistics on a new song. And then we've got a delay time variable, and we're setting that equal to 100. And then the statistics.stat, that's part of the statistics library, and the 100 means it's going to take 100 values of the sound level and perform the standard deviation min and max on those 100 variables. And then in our void setup, we've got a serial begin, which I only use that for debugging, and we're not using that anymore, but I just leave it in there. And then we get some pin modes where we're setting some outputs here for the pins and the shift register and the RGB outputs. And then we have a new function here that we've written. It's called shift right, and we're delivering to that function the pin number and setting it low. That's how we're going to set our 8 LEDs at the output of the shift register, turn them all off when we first start up. And that shift right is a function that we've developed down here, and we're delivering to it a desired pin. This is a shift right up here. The desired pin is pin 7, and a desired state. And up here, we're delivering it a high in this particular area. And then these are a couple of functions that are in the Arduino, a bit right and a shift out. That's how we're controlling the shift register to get the proper pin on the shift register to shift out to the pin 7 and make it a high. And then we've got a digital write of that latch pin, shifting it high and then going back low to shift what we've put into the shift register to the output. So that's how the shift right function that we've written works. So we do a shift right just like a digital write, and it's saying that pin 0 on our shift register is going to be low. And we do a shift right, same as a digital write, and we're going to be putting that low. So we're going to be putting all 8 LEDs at the output of that shift register all low to turn them all off. Then we go down here into our loop that just functions over and over again. And we've got the sound level, and we're setting that equal to an analog read of the output of our microphone amplified, or A1 of the Arduino. And then we're going to perform some statistics on that to get the mean, standard deviation, the max, and the min. And then we've got some timing here that we're setting equal to the amount of milliseconds that this program has been running. And then we get a while statement that we're saying, okay, while the sound level is between the values of 410 to 510, we're going to stay in this while loop and just count the number of seconds that were in there and read the analog A1 pin all the time. And we're going to go down here to a if statement while we're in this while loop and say if the timing that we've been in this loop minus the time it started is greater than or equal to 1,000, we're going to say that, or 1,000 milliseconds, which is a second, we're going to say that we've paused in a song and we want to reset our statistics and start the statistics over again. Then we drop down in here to a bunch of if statements, and what we're doing here is we're saying that the outputs from our microphone are going to distribute themselves, the sound levels are going to distribute themselves like a bell curve, statistical bell curve. And we're going to divide that bell curve in half at the mean. And then to the left of the mean, we're going to divide it into 7 or 8 sections. And those 8 sections to the left of the mean are going to determine which one of the 8 LEDs turns on. And it's going to determine what color our RGB is going to be. Or we're also going to the right of the mean, divide that bell curve into 8 sections. And we're going to say, okay, if we're in a particular section to the left of the mean and the similar section to the right of the mean, we're going to turn on a particular LED at the output of that shift register and make it high. And we're going to turn our RGB on at a particular color. And then we're going to delay by our delay time, which is 100 milliseconds. And then we're going to turn the LED off and turn our RGB off. So these if statements are basically dividing that bell curve up into those 16 different sections. So we've got 8 different if statements here for a different portion of the bell curve. And the control RGB is another function that we've written. And we pass that values on this particular part of the bell function. We pass it a value of the red being 125, green being 125, and blue being 125. And so if we go down here to the function we've written for that, we are doing an analog write of the red LED, and we're giving it the red value, which we said was going to be 125. And then we do a digital or an analog write of the green and of the green value, which we said that was also going to be 125. So that's how this control RGB works. So that's how this function is working. And so I hope you enjoyed today's video. And if you did, please like the video and share the video. And subscribe to my videos so you're notified when new videos come out. Enjoy the Arduino.